Hi everybody, welcome to the Cooling United live event. My name is Ivan and I'm working with applications for heat exchangers in the industrial refrigeration team in Kolding, Denmark. I'm here today to talk about our new product, semi-welded plate heat exchangers for industrial refrigeration, which we in Danfoss Cooling launched more than 1.5 years ago, but have been engineering and continue developing for a period of more than 3 years. How does it work? 2 plates, pressed, welded together, used for applications with aggressive media on one of the sides, which is running inside the welded cassette, and non-aggressive media on the gasketed side over here. As I said, over the last couple of years we have been developing the plate design. We have namely introduced some new features, such as we have changed the heat transfer area. This part here, this is where the heat transfer actually happens. We made more aggressive pitch, meaning more contact points per square meter, which is contributing to the higher thermal efficiency. We have this chevron in 3 plate patterns actually, to utilize in the best way the pressure drop and the thermal performance each time. Furthermore, we have also redesigned the distribution area, or this part over here, which is not efficiently participating in the heat transfer. However, it is very important for even distribution over the channel of the plate and to prevent from dead zones in the area. Then we have also put additional prints in order to support mechanically and make the plate more robust. We put one over here, also here, also inside the port. Then we have also enforced the hanging system, this part here, which is hanging from the carrying bar, this area here, making it easier to service. The new robot helps us to create one continuous line of a weld all the way of the plate. There is enough area inside the gasket groove for the robot to navigate properly inside, and then it is additionally protected from the gasket. Talking about the gaskets, we also have designed new gaskets to the plates. They are consisting of 2 parts, the port ring over here and the main field gasket over here. The port ring is the only part of the semi-welded plate which is in contact with the ammonia or with the refrigerant in general. In the gasketed side, we have in a standard industrial refrigeration application the brine, such as glycol, water, calcium chloride, you name it. The functionality of having 2 separate bodies of the main gasket and the port ring helps us to select the best possible compound of gaskets, as not all gaskets are equally good for both water and for ammonia. So this is helping us to improve the lifetime of the O-rings. Something else, it is also helping us to have our product at a higher reliability level, because there is a double gasket barrier, meaning there is, in case of a leakage from the port ring on the ammonia side, the only place where this is where the ammonia is in contact with the gasket, then the ammonia would go into the drain area, this part over here, which by the way is also a new feature of our heat exchangers, and then will be naturally let out from the plate heat exchanger from an opening here or here to the environment. So we prevent from contamination from the refrigerant side to the glycol side or to the brine side. Double gasket barrier. We also have 100% glue-free gaskets. This is first of all due to safety reasons. If we were gluing all the gaskets, then in case of a leakage from the port ring, there would not be any guarantee that the refrigerant would leave the heat exchanger outside to the environment and not directly through the diagonal. And second reason is, of course, service and maintenance. It's easy to take the gasket out, but it's not so easy to take the glue out from the plate. Last year, we launched the first 5 sizes of semi-welded plate heat exchangers for industrial refrigeration with connection sizes from DN65 to DN200. In 2021, we will launch the 3 bigger or XL size of plates, semi-welded as well, up to DN300. Or in total, for now, we have in the plan to have in our portfolio 8 sizes of semi-welded plates for industrial refrigeration. We have them for the moment in 3 plate thicknesses. These are 0.5 millimeters, which is, by the way, approved for as high design pressure as 25 bars according to PED. I would like to comment why this is important. Selection of the plate thickness in a semi-welded heat exchanger for industrial refrigeration application is purely a function of the design pressure, which means that if the plate is mechanically robust enough to handle the higher design and working pressure, then 0.5 plate thickness is sufficient to handle 25 bars. There is no corrosion allowance in industrial refrigeration applications. Therefore, if you select properly the plate material, then you do not need a thicker plate, like in other, for example, chemical applications where you would extend the lifetime. But this is not necessary here. Furthermore, we have also 0.6 millimeters plate thickness, which has been approved for up to 40 bars design pressure according to PED. We also have 0.7 millimeters plate thickness, which for now we have not defined how far or will go in pressure. However, we are continuously working in approving our plate heat exchangers for more applications. For the moment, they are approved up to 40 bars, which means that we are well covering almost all industrial refrigeration applications, as well as most of the heat pump applications. Something important to keep in mind about Danfoss heat exchangers is that we always launch a new product only when we are 100% sure in its quality and its performance, which means that over the last 3.5 years we have tested it in various ways, mechanical, but also we have tested the performance in a real ammonia installation. We have every one of Danfoss semi-welded plates, every plate size, every plate pattern have been tested and verified performance in a real ammonia installation for the applications flirt evaporator, condenser, desuperheater, liquid-liquid, such as oil cooling, for example, or water-water. All this data we have gathered and have entered in our software, which enhances us to make sharp designs every time we design a heat exchanger. Because we are engineers and we must know the performance. We cannot guess the performance. The next step is testing with helium of the cassettes. Every Danfoss semi-welded plate has been tested already in factory conditions with helium. We have helium actually at 3 stages during the manufacturing of a plate heat exchanger, and the first one starts with testing already after the robot, which is over here. We have the next step in our process is a helium leak chamber, where every single cassette of Danfoss is inserted in order to make sure that there are no cracks in the welding, neither cracks in the plate from the press. Previously, and still used in most manufacturers, is the way of control called visual check, which means that the operator of the machine, after manufacturing the plates, is looking very carefully into the cassettes and looking for some imperfections. However, first of all, there are many cracks which are inside the material, which first appear after months or years of operation due to fatigue. They are invisible even for the best eyes. And secondly, there is always the human factor. If I'm working in factory and I have 500 cassettes, big size as well to check today, maybe for a small hole I'll not be capable to see sometimes, but this may lead to a big problem in the installation later on. Therefore, we trust the machine to test better than our own eyes. We have a small video. After welding each of the cassettes and stacked in front of the helium leak chamber, they have been inserted in it, and each of them has been tested with helium. The goal of the test is to check the tightness of the welds. Within 30 to 35 seconds, the machine is able to detect any leakage through the welding of a plate, which means that we make sure that 100% of our plates are tight, already sent out of manufacturing site. Even though we make additional tests with helium when we have assembled a new heat exchanger, when we have spares, we also need to make sure that when we send a plate pack somewhere far, then this is tight. And the only way to do that is by helium leak detection. And to our knowledge, Danfoss is the only company who does that to 100% of our plates as standard. The construction of Danfoss semi-welded heat exchanger is the head over here containing the connections, which are always made of metal liners, or these parts over here. Our standard is that always Danfoss heat exchanger has metal liners. This is the best quality and durability for a lifetime of an industrial plate heat exchanger. Our standard is that the refrigerant side is on the left and the brine side on the right. However, we have no problems of manufacturing the heat exchanger with mirrored connections or the ammonia side on the right, as long as the customer would like that. Furthermore, we always provide our heat exchangers with count-off flanges supplied, so you don't need to specify it additionally because they're always there. Always our plate packs start with a single plate, which is with 0.7 millimeters thickness, regardless of how thick is the plate. The reason for this is that always the last and the first plates are most exposed to, among others, vacuum, and a little bit thicker material supports or makes the plate pack stronger and more stable. This is also a feature which we always do. The construction of the plate heat exchanger. We have the frame, the head, the follower, tie bars, which keep the construction tight. We have the carrying bar, which carries, obviously, the plates and the whole construction. We have guiding bar in the bottom to help to the maintenance people assemble the plates into a aligned plate pack. One of the good features of our design is we have this nylon roller, which means that opening the plate heat exchanger will be easy, as when you take out the tie rods, then you can slide back the follower and it will be part of the construction, and the plates will remain hanging. Another good feature which we like in the frame is the tightening possibility from the head, because our tie bolts, they are fixed over here. So it gives you some flexibility, and then you can also use the hydraulic tool to help you tighten the plate pack properly. Another feature of our heat exchangers is the lock bush in the back, which supports that the bolt does not get untied during vibrations, such as operation of the heat exchanger, or sometimes even transportation could be a reason for this. This one supports it. The role of the frame in a plate heat exchanger is to keep the construction tight, and we guarantee it. Therefore, we have tested all our heat exchangers in every size and in every pressure rating. We have tested mechanically according to the requirements for 15 years of lifetime expectation of the plates. For example, we have also tested to fatigue, as in the industrial refrigeration systems, due to vibrations and cycling from the compressor. We often see that there could occur fatigue in the welds. Therefore, we have executed tests of all of our prototypes to cycling tests of 35,000 cycles, pressure change from 5 to 25 bars, which resulted quite successfully. This was actually part of the requirement which we had to fulfill in order to approve our plate design for 15 years of lifetime expectation. As I said, reliability for us is everything. Furthermore, we know that over a lifetime of plate heat exchanger, the equipment is exposed several times to vacuum. Already in factory conditions, as you see from our assembly videos, it is exposed several times to vacuum. Therefore, we also had to perform full vacuum test on both welded and gasketed side for 48 hours, which means that the heat exchanger had to be tight under vacuum, which is the hardest condition for equipment or for a plate heat exchanger, for 48 hours. So you don't need to specify that the heat exchanger needs to be tested under vacuum, because all of them are already in factory conditions. About the reliability of our products, I'm confident that Danfoss has the most robust way to test every heat exchanger as a standard. Starting with the test of the cassettes. After drying out the heat exchanger completely on both sides, we perform internal helium leak detection test, which means that we fill the welded side with high pressure helium, and the gasketed side we have under vacuum, and we measure concentration difference between these two leakages from the welded towards the gasketed side. After this has been approved, then we fill both sides, the refrigerant side and the secondary side, with helium, again high pressure, and then we measure concentration outside, which detects leakages from the external part. Once this test also has been approved, then we recycle actually the helium. We have a recycling system in factory, but we fill the welded side with 1 bar G nitrogen. Then we seal it with a blind plate and a counterflange. On the gasketed side, we put a protective plastic cap, and again counterflange, and this is how the heat exchanger arrives to your site. Every Danfoss semi-welded heat exchanger. All of our plates and cassettes are manufactured in Kolding, Denmark. We have our assembly site, the first one which we launched more than 1.5 years ago, also in Kolding, Denmark. From this site we already have delivered more than 200 semi-welded heat exchangers for industrial refrigeration applications. Earlier this year we started local assembly site in the Shanghai area, which the plan is to serve the Asia Pacific market with a faster delivery times, using still Danish plates and the same technology. Actually, the assembly sites are a copy-paste of the original assembly site in Denmark. So the product is the same, manufactured in Denmark, but because of the market lead times, assembled in, respectively, for the Asia Pacific market in Shanghai, or for the Americas market, also with a local assembly site in Louisville, Kentucky. We have even the same sub-suppliers for the equipment of the tests. So it is the same Danfoss product, and we take full responsibility for its performance. Then we have a few videos just to go quickly through our assembly site and the procedures for manufacturing heat exchangers, starting with setting gaskets on the plates. By the way, we have a higher variety of portering materials than gaskets, simply because they're also exposed not only to the refrigerant but also to the compressor oils. And not all compressor oil types are compatible with all gaskets. Therefore, we have tested to exposure to the 5 most commonly used compressor oil types in industrial refrigeration, all our 5 compounds of porterings. As you can see, in less than a minute, you can have a gasket mounted and 2 porterings on a cassette without using glue. This cassette is the same like the one that I have in my hand, which is port size of DN100. The next step in building the heat exchanger is assembling the plate pack into the frame. This is the frame parts, the head and the follower. My colleague here puts the O-ring into the connections, in the inside part of the connections. Its role is to prevent flow of media between the first plate over here, which is single always, and the head. Then we have the first cassette. So always the first channel in our semi-welded heat exchangers is gasketed, followed by a welded, and like this alternating. Here you can already see shaping the honeycomb, so-called. This is typical for our heat exchangers. And here you see my colleague preparing the end plate, which is fully closed plate, which means that there are no openings in the ports. And the next step is to slide the follower and close the heat exchanger. This one in the video is the same size like this one, DN100 connection. So for a single person, I think it is rather easy. The next step is to tighten the heat exchanger, going into the correct assembly measure over here. This one is important, actually, in order to make sure that there is contact between the plates, so they shape the contact points that the heat exchanger performs, that also the heat exchanger is tight, and also not to tighten below the minimum assembly measure in order not to destroy the
plates or the gaskets. This measurement is stated over here on our on our nameplate. But this is how the plate heat exchanger should look after this is assembled. The clip-ons are forming a line and a honeycomb. Now the next step is hydraulic test. They are mounting at the moment the counter flanges for the test, which are with a special connection for our testing machine, which is in the next video. So they enter with water in the bottom, and at the beginning suck air from the top, so they vent the heat exchanger. Now the differential hydraulic test starts, which means that each of the sites separately is exposed to high pressure for a period of half an hour. After the differential hydraulic test of both sides, we also perform balance test. The next step is our dry out procedure. Both sides are being dried out after the hydraulic test in a combination of circulating hot air through both of the sides. After this, using vacuum, and again warming up on the other side, so we make sure that there is no any areas which are frozen under the vacuum. We also use at the very end some nitrogen which is absorbing moist in our test procedure. So at the moment they are circulating hot air to get the raw amount of moist from the heat exchanger. And the next step is vacuum simultaneously on both sides. Over here. We go to full vacuum, or at least as full as the pump can get. This is actually only a preparation for our next test, which is the helium leak test, which are the 2 consecutive helium leak tests, which we have as a final approval for our heat exchanger. This is our helium leak test equipment. You see that the heat exchanger is connected now with other pipes. We start by sucking vacuum on the welded side, going to full vacuum. Yeah, you can see -1 on the screen. There is no any moist, and once this has been approved, or at least the amount of moist is acceptable, almost none, then we fill with high pressure, we fill with 10 bar helium, the welded side, this one here. You can see now the other side starts to move as my colleague opens the helium valve. So from vacuum, it goes to 10 bar helium. Or nearly 10 bar, in this case. There are several green lights that need to show up before everything is approved. And yes, this one is compliant. Good news. The heat exchanger has been approved in our leak test, or internal helium leak test. The next step, which unfortunately the video would be way too long, is the external helium leak test, which is 10 bars of helium on both sides, the welded and the gasketed side, and detected for detection of external leakages. Once this one is approved, then, as I said, we recycle the helium, we fill the welded side with nitrogen, we seal it with a blind plate with a nipple on top. On top of it we mount a counterflange. On the gasketed side we have a plastic protective cap and a counterflange as well. This is standard for every Danfoss heat exchanger. For the moment, we have approved our semi-welded heat exchangers for the following industrial refrigeration applications. These are fluid evaporators, condensers, desuperheaters, subcoolers, oil coolers, both thermosiphon and brine cooled. And as well, we also have from Danfoss heat exchangers, or Danfoss heating heat exchangers. We also are able to offer water-water and glycol-water heat exchanger, as long as this is a part of industrial refrigeration system. In the industrial refrigeration team, we like to apply the knowledge and application experience which we have gathered through all of our industrial refrigeration products, and not only to look into a heat exchanger as an isolated box. We like to design the heat exchanger according to the best fit and operation in a system, rather than just delivering the inlet and outlet temperature which is required sometimes. We see many synergies in this, such as optimized compressor operation, improved COPs. We see many times we can improve our design if we ask the critical questions towards the design of the whole system in order to make the best fit of the heat exchanger and to gain most out of the industrial refrigeration installation. Of course, we see many synergies in offering semi-welded heat exchanger together or along with our other Danfoss industrial refrigeration products, such as our valves, our backbone product, our valve stations, our controls, level control, smart air purger, or intelligent air purger, sorry. We see a lot of synergies in this way. Among others, we also are planning very soon, actually now, we are launching our heat exchanger design software called HVACR for industrial applications. So our main customers and partners will have access to using our heat exchanger design tool to make the optimal design into their system and to simulate different performance scenario of new or of an old heat exchanger. Actually, in future, our vision is that there will be a connection between HVACR, our heat exchanger software, and Cool Selector. So after designing a heat exchanger, the user will be able to design the geometry of the piping, will be able to select their valves. We see more complete solution, more system solution, rather than just one simple component. Therefore, we believe that heat exchanger is not just a heat exchanger, it is part of the industrial refrigeration system and our philosophy. Over the last 1.5 years after launch of Danfoss's new plate heat exchanger for industrial refrigeration, we have delivered over 200 heat exchangers globally for various amount of applications within industrial refrigeration. If you are interested to know more about Danfoss semi-welded heat exchangers for industrial refrigeration, please visit us online or reach out to the local sales responsible in your region. There will be a Q&A session after this presentation where me and my team will be happy to answer all of your questions. Thanks for watching.